we are now dealing with something like this. And this is our damping element. We have different kind of dampers, but the damper that we focus on is the one such that the force is proportional to the velocity. And we know our velocity is what? X dot. So the force is proportional to the velocity. And if that is the case, we can then introduce proportionality. That way. And the constant there is what is called the damping coefficient. Okay, the definitions, I think we have them already. That's the damping coefficient or whatever. But that's C, our damper. Now, the effect of this is such that when you disturb this from equilibrium, there are now two forces bringing restoration. The damper on its own, if you press a damper like this, it pushes outwards. If you push a spring like this, it pushes outwards. So the two of them are doing the same thing. Are we together? Yeah. Which means without thinking too much, sometimes we want to think too much. I'm trying to shorten. I can derive everything. To lengthen it, I can derive that. We did that last time. But to shorten it, we can simply say our expression becomes M. Okay, let me put it this way. We still have acceleration force is equal to restoring force. Our acceleration is still the same thing. That's the acceleration force. Still the same thing. For the restoring force, we had our K minus Kx. Now this thing is acting in the same way as K, which means it also has a minus C. But it's C what? Cx dot. Are we together?
Yes.
Which means our expression then becomes M is equal to minus Kx minus Cx. And we can then say M that's our new equation of motion. Remember, you start there. You start at the equation of motion. That's our new equation of motion. Right. Once we have our equation of motion, remember what we said last time? We want to use it to extract the right kind of the information that we need. And for us to do that, we analyze it. So if we write it here, we go back to maths. This is a second order expression. And we want to find the expression for the displacement out of this. Then we are going to say, if we are in maths, we propose an expression which has a solution which can be like this. And an expression which is like that is x is equal to E. So we simply propose a solution of this form. If that is the solution, then the velocity, simply differentiating this, the lambda comes there, And the acceleration becomes I won't do the full thing. I'll just go to key points and we'll quickly finish this part of it. And if we now substitute into our expression, then we are going to have m plus k